welcome to Math World. Welcome to Math World and Kwasa, that is through Facebook and YouTube. In today's video, we are glad to have hosted my friend and a long-time friend. We have tried to interact through academics, who is Astrophysics. So, in today's episode, we are majorly focusing on the applications of mathematics in space science or astrophysics, meaning that we are going to be encountering some of the questions relating to space science, astrophysics, how mathematics is really being applied in that field. So the person who is here is Mr. Musinguzi Andrew. For the first, we will have to get the introduction from him, and then we can be able to dive into the questions and the package that he'll be presenting to us regarding to what we'll be asking him. Okay, tune in, but don't forget to subscribe to our channel, Math World and Kwasa, and again, be able to follow us on Facebook.
Thank you, Mr. Ankwasa, for hosting me at the Math World Ankwasa. So my name is Musinguzi Andrew. I'm glad to be part of this podcast where we shall be talking about the synergy between mathematics and astronomy. So all of you know about mathematics much. Yeah, now we shall see how mathematics is related with astronomy. Basically, astronomy is the study of everything beyond our Earth's atmosphere. So it is how we learn about our entire universe. So I also happen to have a YouTube channel called Andrews. You can visit it, subscribe to it, and follow for more fascinating facts about the universe. So back to you, Mr. Ankwasa.
Let us directly dive into the questions and be able to present to us the package regarding the question that we are giving to you. Okay, thank you for joining us. Let us. So, diving into the question, the first question is, why is mathematics considered the fundamental language of universe in space science, according to Mr. Andrew?
Obviously, there is no doubt that mathematics is a fundamental language in the universe and space science because it helps astronomers to describe natural laws in a precise and a universal way. Take an example of the universal law of gravitation that tells us about how gravity operates on all objects, starting from small objects here on Earth to massive celestial bodies in the entire universe. So that law is universal in such a way that it operates everywhere in the entire universe. So without these mathematical frameworks, scientists wouldn't be able to decode any information about the universe. So mathematical formulations give scientists a clear framework for understanding these complex phenomena that take place on a large scale. So look at how scientists measure distance between these celestial objects. They need mathematical formalism. How scientists measure motion of planets, stars, and galaxies. So when you look out into the sky, you look at stars as if they are stationary. You just look at them as if tiny bodies just spread in space. So what you cannot even understand is that they are all in motion. Our planets are moving. The sun itself is also moving. So scientists can only use mathematical formulations to decode the motion of these bodies. In conclusion, I can just say that mathematics transforms the observations into scientific laws, making humanity able to understand the structure and behavior of our entire universe.
Okay, direct is the second question. The second question is, how do mathematical equations help scientists predict the motion of planets, stars, and galaxies?
Yeah, thank you for the question. I can say that mathematical equations are able to predict motion by describing how force affects the motion of bodies in space. So scientists have been able to use Newton's laws of motion, Kepler's laws of planetary motion, and Newton's law of gravitation to determine the precise positions of these celestial bodies, their velocity, their trajectory of motion they take in space. So when I talk about celestial bodies, I'm talking about the stars, the planets, the satellites, and the galaxies as well. So take an example of the recent space exploration mission, the Artemis 2 mission, whereby scientists determined the trajectory that will be taken by the spacecraft carrying astronauts to the moon, rotate around the moon, and bring them back. And I believe that without mathematical equations, scientists wouldn't be able to predict such a trajectory. Yeah, also look at the Einstein's law of general relativity. It also tells us about how matter and energy is able to bend space-time. So scientists use it to describe how planets in our solar system, for example, are able to rotate around our sun. Uh, it says that bodies which are more massive, they bend space more, and the ones which are less massive, they bend space less. And that is true. So you can clearly see that our planets are less massive compared to the sun. And when that one happens, the sun bends the space more compared to the planets. And the planets ends up getting trapped into the gravitational pull of our sun. And that's why they are able to rotate around the sun. Therefore, I can conclusively say that mathematical equations are fundamental because they transform physical laws into predictive tools that can tell us about how the celestial objects move within the entire universe.
Third question goes, which mathematical concept is most important in astrophysics today and why?
Well, thank you, Mr. Angwasa, for that good question. Yeah, according to me, the
Yes.
most important mathematical concept in astronomy is obviously calculus. And here is why. When we are looking at astronomy,
Yes.
we are looking at systems that are continuously changing in space and time. And to clearly describe such changes, we need calculus concepts like differentiation
True.
and integration. Yeah, take an example of
Integration.
the rate of change of position with time. This one gives us the velocity of these celestial bodies. Also look at the rate of change of this velocity with time. It gives us the acceleration of these celestial bodies. So
Right.
without mathematical concepts like calculus, astronomy is not possible. But this one does not rule out other mathematical concepts like statistics, geometry,
Yes, analysis
and let's say numerical analysis.
geometry.
They also take a very big part in astronomy. But according to me, I can precisely say that calculus is the heart of astronomy.
Last question is, are there cosmic phenomena where current mathematics is still insufficient to fully explain them? Are there some cosmic phenomena where the current mathematics is still insufficient to fully explain them?
Where I can say yes, these phenomena where our current mathematics fail exist. For example, look at the black hole. A black hole is simply a region in space where matter is packed so tightly in that gravity prevents anything, including light, from escaping. So in these black holes, there are points of singularities where the density
Yes.
and gravitational curvature are infinite. So what does this one tell us? This one tells us at those points the physical laws break down. So implying that there is a need for new mathematical formulations clearly explain
True.
the physics that is taking place at these points. They also look at the concept of the existence of dark matter and dark energy. Dark matter is just simply the material or the mysterious material that binds galaxies together. Where
True.
theories confirm that they exist. This matter exists, but we cannot quantify this. Also, dark energy, which is the force that accelerates the expansion of the universe. From calculations and from observations, there is so much contradiction
Yes.
in that we cannot rely on them. So, I can simply say that even though mathematics is a powerful tool, there are still some mysterious cosmic concepts that need new
That's very
mathematical
true.
ideas to fully
So, Mr.
explain
Andrew,
them.
what is the package or the takeaway you can give to people out there who are having less knowledge about space science, astrophysics, or maybe the whole concept of astrology? What can you leave to them as the takeaway from the concept you are trying to discuss today on the application of mathematics in space science or majorly physics in space?
So thank you, Mr. Ankwasa, for this wonderful session. It has been good interacting with you about how mathematics is applied in astronomy. So the take home I can leave with the viewers out there is that when you look up into space and you look at those bodies, stars, planets, remember that these celestial bodies are not stationary and they are always in continuous motion. And to fully understand these changes or motions in these bodies, you need mathematical concepts to guide you. And also, you have to remember that the universe is so vast, it is so big in that
True.
we cannot fully disentangle it at large. Also, don't forget to go and visit my channel. It is called Andrews. It has more fascinating facts about the universe. Thank you so much for viewing, and I hope to see you next time. Bye.
Thank you to Mr. Andrew. I'm really so glad to have hosted you here. Well, we have interacted enough. Maybe we'll be continuing to get more episodes about space and other concepts that we involving physics, mathematics through this channel. Really, I'm very happy. Don't forget to subscribe to the channel. Visit the channel for Mr. Andrew, that is at Bsc Andrews, and then you can go on Facebook also for my page, that is Math World. YouTube Math World and Facebook Math World. Thank you for tuning in. We'll meet next time.